volunteer training for community strengthening presentation title Ethics of Volunteering Engineering Professional version presented by Chuantat Kang Chuantat. The 8th of July 2016. Engineering ethics explanation. Engineering ethics is the field of applied ethics and system of moral principles that apply to the practice of engineering. The field examines and sets the obligations by engineers to society, to their clients, and to the profession. As a scholarly discipline, it is closely related to subjects such as the philosophy of science, the philosophy of engineering, and the ethics of technology. Reference material, YouTube on Internet, accessed the 9th of August 2016. Michael C. Louis, September 2008, Engineering Ethics 101, Electrical and Computer Engineering, University of Illinois at Urbana-Champaign, United States America, USA. Decision-making. Moral problems. Identify affected parties, rights and responsibilities. Additional information needed. Consider alternative actions. Evaluation of morality of actions. Basic ethical values. Honesty, fairness, civility, respect, kindness, etc. Examples of moral tests. Harm test. Do benefits outweigh others? Short-term and long-term. Reversibility test. Would this choice be good? Common practice test. What if everyone behaves such a way? Legality test. Would such choice violate a law or policy of the employer? Colleague test. What would professional colleagues say? Wise relative test. What would intelligent and experienced relatives do? Mirror test. Would I feel proud of myself when I look into the mirror afterward? Conflict of interest for engineers. Conflict of interest exists when a person in a position requiring exercise of judgment, b. not conflicting interest, c. interference with the exercise of the judgment due to special interest. Unethical conflict of interest, potential bias, perceived deception, loss of trust. Method of dealing with conflict of interest, recusal, disclosure, management. Confidentiality 1. Example, you designed the biochemical reactors that an engineering company hopes to use in future chemical engineering plants. 10 months ago, you left A engineering company for a managerial position with B engineering company, a direct competitor. After a restructuring, however, B's president asks you to lead the design team to develop biochemical reactors for B's planned new engineering plants. The president hints that B is interested in the design concepts that you previously developed at A engineering company. How should you respond? For what reasons? Confidentiality 2. Response. Answer to the President. You would not want me to develop the trade secret of B when I leave. This is a kind of reversibility test. The President should not ask to reveal the trade secret of others when the President does not like his or her trade secret to be leaked to others. Confidentiality 3. Definition of trade secret. Information with commercial value represents an economic investment, required effort to develop, actively kept confidential by owner. Need not be patentable. Violations covered by criminal law. No legal recourse if independently discovered. Unlike patent obligations to former employers. Confidentiality of trade secrets. Promises in signed non-disclosure and non-compete agreements. Responsible engineer. Various kinds of personal responsibility, causal, role, legal, moral. Engineers are morally responsible for safety. Code of Ethics, National Society of Professional Engineers. Engineers shall hold paramount the safety, health, and welfare of the public. When you see unsafe objects or practices, you are professionally responsible to act even when you are not assigned the task. Sample of Code of Ethics. Example of IEEE Institute of Electrical and Electronic Engineers Year 2006. 1. To accept responsibility in making decisions consistent with the safety, health and welfare of the public, and to disclose promptly factors that might endanger the public or the environment. 2. To avoid real or perceived conflicts of interest whenever possible, and to disclose them to affected parties when they do exist. 3. To be honest and realistic in stating claims or estimates based on available data. Sample of Code of Ethics. Example of IEEE Institute of Electrical and Electronic Engineers Year 2006. 2. 4. To reject bribery in all its forms. 5. To improve the understanding of technology, its appropriate application, and potential consequences. 6. To maintain and improve our technical competence and to undertake technological tasks for others only if qualified by training or experience, or after full disclosure of pertinent limitations. 7. To seek, accept and offer honest criticism of technical work, to acknowledge and correct errors, and to credit properly the contributions of others. Sample of Code of Ethics. Example of IEEE Institute of Electrical and Electronic Engineers Year 2006. 3. 8. To treat fairly all persons regardless of such factors as race, religion, gender, disability, age or national origin. 9. To avoid injuring others, their property, reputation, or employment by false or malicious action. 10. To assist colleagues and co-workers in their professional development and to support them in following this code of ethics. The NSPE, National Society of Professional Engineers, Code of Ethics, Year 2007. Preamble. Engineering is an important and learned profession. As a member of this profession, engineers are expected to exhibit the highest standards of honesty and integrity. Engineering has a direct and vital impact on the quality of life for all people. Accordingly, The services provided by engineers require honesty, impartiality, fairness, and equity, and must be dedicated to the protection of public health, safety and welfare. Engineers must perform under a standard professional behavior that require adherence to the highest principles of ethical conduct. Rules of Practice, Year 2007. 24B. Engineers shall not accept compensation, financial or otherwise, for more than one party for services on the same project, or for services pertaining to the same project, unless the circumstances are fully disclosed and agreed by all interested parties. Definition of engineering. ABET, Accreditation Board for Engineering and Technology. Engineering is the profession in which knowledge of the mathematical and natural sciences gained by study, experience, and practice is applied with judgment to develop ways to utilize, economically, the materials and forces of nature for the benefit of mankind. Characteristics of professions, engineering, etc., professional accreditation, licensing, associations in engineering, Engineers Australia, Institution of Engineers Malaysia, IEM. Community sanction, special knowledge and intellectual skills, professional authority, judgment, peer review, formal education, often graduate degree. Special ethical responsibilities of professionals, engineers, etc. Through Code of Ethics, profession serves a public good. Clients of professionals must trust the professionals. Moral theories in engineering. 1. Ethics equals formal study of morality, namely moral standards of particular group, engineering ethics, medical ethics, etc. Morality equals actions that ought to be done. Character that a person ought to be, values that one ought to adopt. Consequentialist theories emphasize consequences of actions, assess good and bad consequences, both individual and others, both short and long term. Act utilitarianism, choose action with greatest net benefit over costs. Rule utilitarianism, choose rule with greatest net benefit. Practical difficulties in consequentialist theories, assessing chance occurrences, measuring on common scale, e.g., cost of life, distribution of benefits may seem unfair. Deontological theories emphasize duties and rules. Kant's categorical imperative, act according to that maxim which should be a universal law. Rawls' theory of justice, rules that rational persons would agree to follow, not knowing their actual positions in society. Moral theories in engineering. 2. Most individual liberty compatible with equal amount for others. Differences in social and economic power justified only if all benefit, including disadvantaged groups. Important duty, treating people with respect. Golden Rule test, philosophy, Confucian form, do not do to others what you would not want them to do to you. Christian form, do unto others as you would have them do unto you. Rights and duties are reciprocal. My right not to be deceived. Your duty to tell truth. Kant's categorical imperative, alternate form, treat people as ends, never as means. Gewerth's hierarchy of rights. First tier, required for existence, life, health. Second tier, maintenance of self, not being cheated, not suffering broken promises. Third tier, enhancement of self-property acquisition, self-respect, achievement. What should we do when duties-rights conflict? Answer: create solutions that honor all rights. Example of conflicts between rights: individual privacy vs. airport security. Philosophy of Engineering 1. The philosophy of engineering is an emerging discipline that considers what engineering is, what engineers do, and how their work impacts on society. As such, the philosophy of engineering includes aspects of ethics and aesthetics, as well as the ontology, epistemology, etc. that might be studied in, for example, the philosophy of science. History. Engineering is the profession aimed at modifying the natural environment through the design and manufacture of artifacts. It might then be contrasted with science, the aim of which is to understand nature. The philosophy of engineering is then the consideration of philosophical issues as they apply to engineering. Such issues might include the objectivity of experiments, the ethics of engineering activity in the workplace and in society, the aesthetics of engineered artifacts, etc. While engineering seems historically to have meant devising, the distinction between art, craft and technology is not clear-cut. The Latin root ars, the Germanic root craft and the Greek root techniol originally meant the skill or ability to produce something, as opposed to, say, athletic ability. The something might be tangible, like a sculpture or a building, or less tangible, like a work of literature. Nowadays, art is commonly applied to the visual, performing or literary fields. Especially the so-called fine arts, the art of writing, craft usually applies to the manual skill involved in the manufacture of an object. Whether embroidery or aircraft, the craft of typesetting and technology tends to mean the products and processes currently used in an industry, the technology of printing. In contrast, engineering is the activity of effecting change through the design and manufacture of artifacts, the engineering of print technology. Ethics distinguishes engineering design from artistic design is the requirement for the engineer to make quantitative predictions of the behavior and effect of the artifact prior to its manufacture. Philosophy of Engineering 2. Such predictions may be more or less accurate but usually includes the effects on individuals and/or society. In this sense, engineering can be considered a social as well as a technological discipline and judged not just by whether its artifacts work, in a narrow sense, but also by how they influence and serve social values. What engineers do is subject to moral evaluation. Modeling, socio-technical systems, such as transport, utilities and their related infrastructures comprise human elements as well as artifacts. Traditional mathematical and physical modeling techniques may not take adequate account of the effects of engineering on people. The civil engineering discipline makes elaborate attempts to ensure that a structure meets its specifications and other requirements prior to its actual construction. The methods employed are well known as analysis and design. Systems modeling and description makes an effort to extract the generic unstated principles behind the engineering approach. Product life cycle. The traditional engineering disciplines seem discrete, but the engineering of artifacts has implications that extend beyond such disciplines into areas that might include psychology, finance and sociology. The design of any artifact will then take account of the conditions under which it will be manufactured, the conditions under which it will be used, and the conditions under which it will be disposed. Engineers can consider such life cycle issues without losing the precision and rigor necessary to design functional systems.